Hello. After a whole chapter of studying the ins and outs of quadratic functions and doing finding x-intercepts and vertexes and completing the square and vertex form, quadratic formula, all that stuff, this video is going to try to attempt to put all those pieces together to show how we can use those tools to complete quadratic analysis. Now remember, analysis is essentially to take all the details that we learn about a function and break it into small little chunks, little pieces, like the intercepts, the axis of symmetry, vertex, and so forth, and then use all those little pieces to understand the greater picture. So, to complete the analysis, we need to make some observations right out of the gate. First of all, I like to determine if the function's in standard form, is it factorable or not? That's going to have some bearing on the path that I follow to find all my analysis here. But first, again, observation, is it factorable or not? Yes, it is. Next, make a quick sketch. Shows all the solutions to the equation. So again, the idea here is it's going to be a parabola that opens up. We're going to have a positive y-intercept, and then we're going to dip down a little bit before we turn back around. So that's what this is indicating. So when I find my x-intercepts, I should expect to see two positive x-intercepts. Anyway, the rest of the analysis is going to follow as we've seen throughout this chapter. Find the y-intercept by evaluating f of 0. So we got 0, 2. Axis of symmetry, we can use the opposite of b over 2a to get 5/6, which is consistent with my graph. That is to say, the axis of symmetry had better be a positive number. I don't go any further until I've made sure that's at least consistent. Then I evaluate f of 5/6 so that I can find the y value of the vertex. One thing to remind you of here is the first term should always be half of the second term at the axis of symmetry and opposite. So that's what I have, and this gives me the location of the vertex. Bonus point, don't forget the bonus point. Oh, sorry, the x-intercepts, let's do that. When y equals 0, we put in 0 for y, and we follow the factoring process to find that x could be 1 or 2/3. And one thing to check real quick is the axis of symmetry halfway between your x-intercepts? And 5/6 is exactly halfway between 2/3 and 1. You can take my word for it, or you can check for yourself. Anyway, the bonus point here is the last thing that I get, and that's based off of symmetry. If I have a point at 0, 2, then on the other side of the axis of symmetry, I'll have another y value equal to 2. So to do that, all I have to do is double the axis of symmetry. Double 5/6 is 5/3. I know that f of 5/3 will be equal to 2, in the same way that I know that f of 0 will be equal to 2. Put all those pieces together, sketch a detailed graph, and then all the pieces that you found in your analysis should show up as labeled points on the graph itself. And just to make sure everything was done correctly, I put this into the graphing calculator and make sure that all the pieces that I found in my analysis match what I did. Now, quickly to contrast here, when I make my mental sketch, again, we got parabola opening down, y-intercept is positive. That means we're going to have a positive and a small negative x-intercept. But before I go any further with my analysis, I'm going to make the observation that this expression is not factorable. That's going to have some bearing on how I choose to solve or do my analysis. You see, what I'm going to do now is actually start with the x-intercepts. You let f of x equal to 0. Well, first I'm going to complete the square, which we kick out the 2, put in a 4 in its place, which is a net of subtracting 4 rather. So I add 4 to keep the balance, and I get these results. I'm going to stop for a second. This is the vertex form of the equation. Now I can replace y with 0 and do some very simple algebra and get x is 2 plus or minus the square root of 6, which estimates at around 4.2 or 4.4 and negative 0.4-ish or something like that. So I've got my estimates, I've got my x-intercepts, but since I knew this was not factorable, I kind of went down this path of completing the square, not just so that I can get the x-intercepts, which is definitely a good thing that I can do, but it gave me the vertex right out of the gate. So now I can find the y-intercept real simple. I could find the axis of symmetry now just from this form, vertex form, x equals 2, and I could find the vertex as 2, 6, which I get from vertex form. So you see, by recognizing that it's not factorable, then I go to the complete the square process. That tells me what my x-intercepts are and my vertex all in one easy go. Now I didn't do that in the other case because it was factorable, and since it was factorable, I didn't need to put it into vertex form, which means I could find the vertex using my alternative approach. So this is just logic and trying to be efficient in my work. Anyway, once I have the bonus point, x-intercepts, all those pieces, put it together in a graph, and I label all the key points that I found in my analysis, and I check it against technology to make sure it's all done right, which it is. Finally, in this situation, I see a function which is already in vertex form for me, which makes it easy to draw the mental sketch. I can see over 5 up 6 opens down. I get all that bit. But I don't have to do any factoring or completing the square because that's already been done. So I need to find the y-intercept, which is a very large negative number, the axis of symmetry, well, that's given as 5, and 5, 6 is given as the vertex, so all that's free. Finding the x-intercepts then, it's already in completed square form, so I just do my algebra of taking inverses of both sides until I get the value of x, and I approximate. Bonus point on the other side of the axis of symmetry of 5, so x is 0 or 10, y would equal negative 44. Both of those points, by the way, are too large to plot and make a reasonable graph, so I'm going to basically just accept their existence as way down below and farther than I could graph and make a reasonable looking parabola. So once again, I label all my pieces, I check it with technology, and I'm good to go. So hope you find this helpful, and remember to think as you work. The idea behind all of this is if you do all of this work right, then everything about the parabola is going to fall into place, and it's going to look like a parabola should look. If you do anything wrong in any piece of this analysis, it's going to show up as something that's non-parabolic in nature over here. So just be aware of what you're doing and realize that all of your analysis is self-checking. So think about your answers within the context of the big picture and make sure everything's lined up the way it should be. Have a great day.